Thank you for coming. My name is David Mattis. This is my first time to Sofia, and so far I have a great impression of your country, your city, and all of the people here. Everybody I've met's been very, very intelligent, very stylish, and very, I'd say diligent and engaged. So people take their work seriously, and I think that's fantastic. I'm really happy to be here. I'll share a little bit about my journey in tech, and I think with all journeys, you never really, or you usually don't anticipate where you end up. You just kind of look at yourself and, wow, how did I end up here, right? So, but I started out as an electrical engineer, and then thought I would study robotics and virtual reality, and then I ended up in grad school, I ended up doing sperm whale acoustics, and then doing medical imaging, and then doing some virtual reality and robotics, and then I ended up at Boeing. When I was at Boeing for 10 years, and what I thought I was going to do at Boeing ended up being completely different from where I ended up. So, I was hired to, do virtual reality with training people how to drill straight holes in the fuselage, and then Boeing was like, this virtual reality stuff doesn't work. So all of a sudden, I'm doing networking and security in the factory, and so I didn't know the first thing about networking. So so we just find ourselves constantly exposed to new technology, new challenges, and the thing that I found to be the most important thing I ever learned in school was just learning how to learning how to problem solve, and debug and figure things out, how to hack. And so I did a lot of work in networking, and then I built some cool tech at Boeing, but Boeing didn't know how to take this internal technology and use it. So it was going to wither on the vine, they say, the chasm of despair, when you try and throw things over the wall and nobody's there to catch it. And so I left and I started a company based on that, and it was a networking security company, software-defined networking, and did that in Seattle, and that did that for 4 years, and that startup's still going. It's doing great, and then I had to go back to work, because you want to feel passionate about, you want to feel like you're engaged in something that's fulfilling, and you want to be still in technology, you want to stay relevant. And so what I ended up doing was meeting up with some people who had a cloud security, cloud DevSecOps startup called Cloud Choreo. And these three folks had gotten together and founded the company, and I was their first employee. And we worked on that for about 18 months or so, almost 2 years, and then VMware bought us for $6 billion. No, just kidding. Nothing like that. But VMware did buy us, and after I left Boeing and had done a couple of startups, I swore to myself I would never work for a big company again. That was just not where I could find what I was looking for. But I have to say that VMware is not what I think of as a typical big company. We've been able to still act like a startup. We've been, in fact, told to act like a startup, which means stay focused, ignore all the process and and all the other things going around you, and also be completely responsible for your service. So own it, the entire thing, full life cycle of the service, and that's what we do. I think that, and then to move fast, you know, and I think we've been very successful. So we were acquired in February last year, and we've been really successful at keeping our culture. You know, we have a fail fast, fail forward, growth mindset culture, absolutely, and where we trust each other and aren't afraid to look stupid in front of each other, and we support each other. And so VMware has been very supportive of that. It's got an incredible R&D mindset, and really supportive of the people taking risks and trying things. So, great company. By the way, you know, I am plugging VMware for a reason, right? I'm here to try and build a team based on the technology that I'm going to share with you today. So, you know, just real quick about VMware, right? So VMware is about 20 years old, and they started a technology transformation, right? An IT transformation in virtualization, right? 20 years ago. And that just was, I don't know if there's been a larger technology transformation in the last 20, 25 years until now with public cloud, right? And so VMware now has to be relevant in this new technology transformation that's happening. And they are taking that challenge head on, and that's really encouraging, right? So, and they're acquiring companies like Cloud Choreo, where I was, and Cloud Health, and Heptio, and really making building out a cloud services, a cloud-first, cloud-native technology portfolio. So, right, so, well, you know, I'm going to just talk a little bit about public cloud and the challenges that we have there, and then talk about what we're doing. So when we got acquired, Cloud Choreo was rebranded to Secure State, and so I'm still like absorbing that, you know, that change, but, you know, I'll be calling it probably both a little bit. So talk to you about what we're doing, why we're different, and why we're relevant, and then talk to you about a really kind of an exciting discovery we made in our startup journey that VMware really wanted us to expand on, which is a data model for connected data that we can open up eventually for broad application usage. Okay, so let's see. How about, I just want to ask who here is using public cloud or has used public cloud services? You know, okay, yeah. And who's on Amazon, AWS, you know, and Azure, Google, Alibaba, okay, Oracle. Wow. Okay, yeah. So I get a couple. So and then who here is like getting like security considerations put on them around the usage of public cloud, being governed and being asked to respond to security issues in the public cloud? So not so many. So public cloud, it's kind of like opening up a new virtual data center and giving the developers the keys to the door, right? It's letting them come in and do anything they want in these environments, right? So it's a tremendous amount of power that's being given to the developer, and developers are, they're lazy. They're goal-oriented, shall we say, and so there can be. You could imagine if you just opened up a traditional data center to everybody, they would come in and put their own servers in and plug things in, move cables around, and it'd be a mess, right? It would be an absolute mess. Well, public cloud it's kind of a mess, right? And in most of that mess is is stuff that people are doing to themselves, right? Like the public clouds are doing a great job of securing their infrastructure, at making their services secure, at ensuring multi-tenancy. But still, people at like all these brands are making big mistakes, right? And we're hearing about it a lot, right? So I'm sorry, I don't have any Bulgarian brands to put up here. I don't even know if there are any Bulgarian brands that would be up here, right, or even European for that matter. So I don't know. I guess I'll admit I don't know the European and Asian cloud landscape nearly as well as I do the U.S. one. So, but to date, 80% of breaches in public cloud have been due to people, developers coming in and hooking stuff up the way they want to, right? So what does that mean? It's misconfiguration, typically. These APIs are incredibly rich. There's so many ways to access these services, right? The cloud services, through the console, through CLI, through SDKs, through automation, through scripting, templates, and all this stuff is happening all the time. And it's just so easy, it's almost impossible not to have some kind of configuration issue that leaves an environment vulnerable, exposed, right? And it's very easy for adversaries to take advantage of these misconfigurations, right? You only need to have a bucket open for a minute or less for somebody to siphon all the data out of it, right? Defending is always much harder than attacking, right? There's always that asymmetry, and with so many configuration changes happening, the opportunities for adversaries are just are limitless. So the services we're deploying in the public cloud are complicated, right? There's a lot going on in there, right? And as the complexity grows, the challenge just multiplies, right? And if we look at a large enterprise, it becomes multiplied. It's like a cross product of complexity, because you have all these different layers riding on top of the cloud infrastructure, right? You have your services and serverless functions. You have the apps, the host. You have Kubernetes running inside. You have all kinds of stuff on top, and the cloud infrastructure itself, right? So it's this multi-layered. You have thousands, tens, hundreds, thousands of accounts, right, that are being used to run different services. They're being connected together. They're cross-linked, cross-connected. You have your teams, like I mentioned. You have this democratization of power across the cloud services landscape and the ecosystem, and you have all these environments, right? There's just so much here, and the cloud providers have, like I say, they've done a pretty good job, right? They use what they call a shared responsibility model, right? Have you guys heard that term, right? So they take care of their stuff, you take care of your stuff, right? And it's on you. But what it's really turned into is a distributed responsibility model for the consumer of the cloud services, right? Because there's so many people, and that responsibility gets distributed. When you distribute responsibility across a lot of humans, guess what happens, right? It doesn't look good. And so you've got, then at the top, trying to wrap their arms all around this stuff, you have security, right? And they're being overwhelmed with the thousands of configuration changes that are happening daily, and trying to separate the signal from the noise around the kind of things that are going on, right? So there's just so much going on. You have the platform engineering team that they're trying to, govern and minimize cost and provision and support best practices and put guardrails up, right? And they have a hopeless job too, because people just, it's just software. Some people find ways to circumvent this stuff. How can you put guardrails up when you can go in through a console, or through a CLI, or through the SDKs, or through all kinds of different paths? So this just becomes this tremendous cross product of complexity, and and it can be really impossible to identify the source of issues, much less know what to do about it, right? So how is security supposed to react when they see a problem? You know, they don't understand the context. They don't understand why something's being done, if it's being done for the right reason. So they just end up throwing things over the wall at the developers. And you know, if developers are receiving like thousands of tickets for cloud configuration issues, what do you think they're going to do? Backlog, right? So it's really hard. You know, so what are we trying to do about that, right? We're trying to, you know, so Cloud Korea was founded by a guy, Paul Allen, no relation to the recently deceased Paul Allen, but that's his joke. I stole it, but he came from you know, a world where he grew up in cloud, and you know, he grew up in DevOps, and he's all about automation, right? So his focus was really on how can we just make this all easy for the developers, right? Make it developer friendly, developer first, so that the developers can internalize best practices around their cloud deployment, cloud infrastructure as code activities, right? How can they learn about these things and apply these best practices easily and in an automated and in part of their, you know, CI/CD pipelines? And how can we give people the insight into the problem, how it fits into their infrastructure, how it affects their infrastructure, and what to do about it? And how can we help them solve these problems so that they're both not happening, they're not happening for very long, and then hopefully they are fixed before they ever get released. So how can we, you know, in the DevOps landscape, in our DevOps kind of jargon, they talk about shifting left. That's a term where it means like, can we move kind of security closer to the developer so that they become part of this process, a partner in this process, rather than, you know, somebody on the other side of the wall that's just getting stuff thrown at them. And then how can we, you know, if we want to be developer friendly, how can we make this look like code? How can we make software that behaves in similar ways to the other kind of to the cloud infrastructure SDKs that are being used, right? Can we leverage Git? Can we leverage CI/CD? You know, can we make this fit in to the way developers work today? Right. So the way we kind of stay developer focused is, you know, security as code, right? So let's take an object-oriented approach to things, right? And support inheritance, overriding, you know, put everything in Git, right? Support pull requests, right? Support the traditional developer workflow, right? Integrate with Jira when things are, you know, wrong, or Slack, or whatever kind of collaboration tools are being used. Integrate with Jenkins. Let people customize the security rules for their environment, right? You know, that's the thing about the shared responsibility model, is what's right for one team is not right for another team, right? Sometimes it's completely legitimate to have an open S3 bucket. You know, sometimes that's a disaster. You know, sometimes that being said, there are certain things that are most likely always wrong. We call those. So if there's something that should never, if there's a configuration that should never be, right, then if you have a rule that detects it, that you would call that having a low false positive rate, because nobody would ever come to you and say, oh yeah, I meant it to be that way, right? An S3 bucket's not a good example of that, just being public, because, you know, lots of people have good reason. But an S3 bucket being accessible by any authenticated AWS user, that's probably not ever needed, right? It should either be completely public, right, or private, but not like just an authenticated user thing. And it's not, you know, and these things are not obvious, these subtle differences. So that's why, and we want rules to help people find these things, and we want these rules as code, and we need people to be able to suppress things, of course, right? So, and to have a workflow around this suppression, because you're going to have the security team, you're going to have the DevOps team, and they're going to have a conversation. And can these suppressions even look like pull requests, right? Can we make this look like kind of a developer-friendly workflow around this stuff? So. By the way, I know I said I'll save time for Q&A, but if anybody has any burning questions along the way, please let me know. So, what do we find? We find all kinds of issues like, here's AWS. All authenticated AWS users can write to a bucket. Open databases, publicly accessible databases, databases that aren't automatically upgrading. We have a couple hundred rules already in AWS and Azure, and we want to make it very easy for people to author their own rules and make those customizable for their environment, and define rule sets that are particularly applicable to their situation, right, to their scenario. But in our journey to make our service applicable to the DevOps world, right? What we wanted to do was be really fast about detecting violations, configuration issues, right? We wanted to, because if you take a long time, nobody's going to wait around for it, right? And so if you can do it fast and tell them tell the developer, hey, you just created an S3 bucket and it's public, and did you know that? And if you can do that within 10 seconds, 15 seconds, then it's very likely then that the developer will respond to that as part of their iterative development process, right? So, but what we found was that doing this real-time stuff was very hard, because the way our service was working is we'd get a read-only role from the user, right? And we would go use all the read APIs to grab all the account configuration information, and our rules would just check the API returns against specific values, right? That's basically what we're doing. We're matching API returns against desired state. And if it does not match, then there's a violation, right? So it's very, very simple concept about what a violation is, right? And but in Amazon and in on all these clouds, the configuration of one object can be very intertwined and related to configuration of something else, a completely different service, right? So you can have, like, for example, CloudTrail logs to a bucket, right? Those are completely different services. And if you want to check if your CloudTrail bucket is public, which would be pretty bad, that's hard to do. So it's hard to do when somebody just creates the bucket or creates the trail without knowing that you need to go look at all these different things. When you get an object event, knowing what that object is related to or connected to was difficult and was preventing us from providing real-time results. Like, we were missing things. We were missing the full picture. We had no knowledge of the relationships of the objects that are being changed right now to the broader configuration in Amazon. And so basically what we realized is we need to build a model of the public cloud. And this was like just a kind of one of those startup moments where you're like, shit, this is not working, right? Our whole premise about shifting left and being developer friendly is not working, and when we had to kind of pivot our whole tech stack and just like rethink this. And we said, okay, we're going to build this cloud model. It's going to be modeled as a graph object, and we're going to put a publish, search, and subscribe semantic on top of that, where these subscriptions are queries that look for violation of configuration, right? And we're going to then, whenever there's a change in this, whenever one object changes, then it changes in the context of the broader graph. So that was like kind of a key insight. And then when VMware acquired us, so this was last February in 2018, they saw the power of this data model and said, hey, you guys need to separate these two things, because this connected data graph data model is very valuable on its own, right? And that your SaaS service that's doing kind of configuration checking for security risk is really just one application of a connected data service that has those properties that I was talking about, right? So they asked us to separate these things, and then so we have these kind of this engine that was doing all the scanning of the cloud configuration, and we had a way to do these queries and internal APIs, and so now we turn that into a public API with a cloud SaaS service sitting on top of it, right? So let me talk to you about this connected data service. We ended up calling it Rosetta because, I don't know, it felt like it was translating between the cloud environment to something that could be queried and modeled, right? So, and so we do a full inventory model, and we have ways to just generate code that calls every get list and describe API method in the SDK, and go grab all the objects, and we model them as each object comes back, and we model them as graphs, and you have to do work to make sure that when you get one thing back from one API, you get something back from another API, and they really are talking about the same thing. You have to make sure they're called the same thing and that they connect to each other in the graph. And then we implemented a search and subscribe semantic on top of it. So if you would imagine, like, what would this sound like? So search would be like, tell me all the S3 buckets that are public in my graph, right? That would be the search. And then the subscribe would be like, tell me whenever there is a change that happens that makes an S3 bucket become public, right? So then kind of an asynchronous search is the subscribe. And then we had this notion of hooking up an event stream to this data model to keep it up to date, because running a full inventory is expensive, right? And the clouds throttle your API usage, right? So the last thing we want to do is be inventorying all the time to keep this cloud model up to date. So instead, we take what we call an event stream. And this event stream is really just a trigger to go do a very micro inventory on an object that changes, and to put those changes in the graph, and to target those changes to the specific subscriptions that care about those things and generate new results if there are new results. So yeah, and it's just the explore hole, the explore. So I don't know. So the people that have been using cloud, right? So they have the console and they have the CLI SDKs. You go into the console and you get one perspective view of some service and the configuration, right? And then you go to another service and you kind of get this other perspective, and you go to another one, you get this other one. So it's really, really difficult to kind of have a full, complete mental model of the way these big, complex services are configured, right? It's really almost impossible. And so one of the most amazing things about putting them in a graph is you start to see how all these different cloud service elements end up being connected. And you can look at them as kind of, oh, this is one big thing, right? And so, like, if all these little things are VPCs, it becomes immediately obvious where your important VPC is, right? It's like, oh, it's this big cluster down here, right? And so, just kind of the nature of graphs and the way they cluster data makes it very clear where you should start looking and where the valuable assets are, right? And that's another thing we learned is that, you know, not all violations are equal, right? There could be, you could have, let's say, you could have security groups in all these VPCs that let SSH traffic come in, right? Which is not it's bad practice, right? So these could all violate that rule. But yet, if this VPC violates that rule, there's probably a lot more risk associated with that, right? So we've introduced also this notion of like a risk score, where we want to capture the more valuable assets in your cloud environment and highlight those for you, because like not all critical severity violations are equal, right? They're the ones that affect your production environments and your critical assets are the ones you want to be looking at first, right? And again, like, you know, environments have thousands of violations, right? So separating the signal from noise has never been more important. You know, how can we help people ignore the stuff that matters and focus on the stuff where the real risk is, right? So, you know, how do we? So here's just kind of another like picture of this. You know, I guess I've been talking about that already, but we have, you know, the inventory engine. This domain plugin is kind of a key thing when you talk about other people leveraging Rosetta as a connected data store, right? So the two key things that anybody would want to use this has to think about is creating the model, creating the domain model, right? So we've built a domain model for Amazon and Azure, and we need to do one for Google. I'd love some of that work to happen here. And so you have to then, you know, read the APIs and model the returns, and that should be customer code, right? Anybody should be able to register a domain plugin in order to build a model of an API connected environment, right? And this doesn't have to be cloud. It could be GitHub. It could be anything that has an API and that, you know, has data that you would want to model as a graph. You know, but the flip side of that is it's not enough to just have a model. You need to have queries that find interesting things in that data, right? And for Secure State, these are security queries, right? We care about vulnerability. But, you know, for I don't know, like a GitHub model, you might care about check-ins or, you know, code reuse, things like, right? There could be, you know, different use cases around this. You know, and then the query is really more around like how would people want to interact with the model itself to explore what kinds of things, how would you represent that information? You know, there's a lot of UX challenges around that, because you can imagine these graphs have hundreds of thousands of nodes in them, right? You can't just put that on a screen, right? There has to be really a lot of thought going into how people are going to interact with this data. So, and this is Secure State. You know, we have other apps in mind that we'd like to build on this. And then we want our partners and customers to be able to build apps on as well. So that's how that looks to open that up. And then, you know, so what does the inventory look like? So, you know, it has to make these API calls. I'm sorry, this is really very unreadable, but it takes a domain expert to write these things. You have to know what you want to ask about and how you're going to model it, right? And like, you know, you're going to have to build like nested queries that go find, you know, for in this example, go find users. And then for each user, find their groups. And then for each group, find the policies, right? And build this out as a connected graph. You know, so that is just an example of how that kind of nesting is happening. And for AWS, you know, it's really interesting. We have this kind of experiment going. For AWS, all this inventory code was auto-generated, which is kind of scary, right? but very fast and very fast to do. There's auto-generated, and there's kind of like this custom language we built to make sure, like I said, that if an object is called one thing when you call the users, and that it gives the groups, but then when you call the groups, it calls a group something different to make sure that those things connect. So we have kind of this language for that around transformation of data for specific API calls. And then for Azure, we did it much different. It's completely prescribed, right? We defined a schema right out of the gate based on the APIs, and everything is very specific. And the API calls that we're making in Azure we're only making the ones that we need to support the use cases we care about, right? Which is security rules and some exploration. The AWS domain model, on the other hand, the schema is dynamic. It's kind of auto-generated on the fly. And so we have these two extremes going. And we don't know what the right path is yet, which is kind of this really, and there's a lot, it's becoming one of these sort of polarizing discussions in the team, right, where people feel very strongly one way or the other. I personally think we're going to, when we do the Google one, we're going to kind of go down, go in the middle and compromise on both sides, because I think there's benefits to both, right? So it'll be interesting. But essentially, we want to get these data graphs in, and then and so then what this looks like to one of our a customer who would want to implement their own domain model is we have a controller as part of Rosetta that takes your code, and your code exposes some APIs, and it's hooked up through gRPC. And then we'll call, when we want to do an inventory, we'll call an initialize. We'll call an initialize, which will set some secrets. It needs a role, it needs credentials to call the APIs, right? And those are customer credentials. And then it will have this cron run, which is like the inventory that happens periodically, daily, weekly, or something, to just kind of get a baseline of everything. And then we'll also have the event stream hookup will work when we get an event, whether it's a CloudWatch event or any just kind of trigger, really. We'll call the process event API endpoint to do, so the code can do whatever it needs to do. The code processes the events, it gets API returns, it turns that JSON return into a desired graph, does some metrics, and then it calls this send nodes method, and then that sends the data up into the graph database. And then the whole point, like I was saying with Discover and Search, is these graphs become extremely complicated, and it really can be very difficult to whittle down a lot of information into a specific subgraph of interest, right, so that you can see what it is you need to see. So, what we're trying to deliver, as I mentioned, with Rosetta now, we can deliver on that promise of real-time security updates that can integrate into a CI/CD pipeline. So if you have Jenkins, and Jenkins has a job that's spinning up a bunch of cloud resources, well, you can. We have a Jenkins plugin where you can have your plugin tell Secure State to give you results based on the objects that are being created in this job, and have those results pushed into the plugin, and then the plugin can fail the build if there is a violation of the rules that apply to your environment, right? So we can't. We're not simulating the deployment. We have to actually look at a real deployment. But we can, our goal is to provide results fast enough so that people will use it. And then, if the build fails, well then, the engineer cares, right? They're going to fix it, right? So it's always better to catch the bugs before they go out, right? It's always better, always easier. And yeah, so with Amazon, we get the real time with the CloudWatch events, and then also by having the environment modeled, like I said, you get a better understanding of the full context of your application and all the connected configuration and service pieces that are in there. And you can get these notifications wherever you want. So you can get them sent to Slack, right? So in this example, we have they're making an Amazon S3 API call, and making a public bucket, and then we have in Secure State we have a Slack notification, Slack integration, and an alert defined to say, hey, if I get any S3 open bucket violations, put them in this channel. And so within our goal is within 10 seconds to have a message in that channel. 10 seconds of receiving the event. CloudWatch, they have their own SLA, but when we receive the event, which is usually within a few seconds of the action happening, we want to be able to alert. But really, one of the really differentiators of this approach is finding what we call connected threats. And this is a situation where, typically we'd been looking at, configuration challenges. Like I mentioned, you'd have CloudTrail turned on. You have CloudTrail going into an S3 bucket. You want to make sure that S3 bucket's not public, right? So that's, we're just looking at a couple of services there, maybe 3 services. You got CloudTrail, bucket, and IAM policy, right? So, but this is an example of a rule that's looking across 11 different things, right, to look for a very specific scenario. And this one's pretty cool, right? So this was previously impossible to detect because nobody in their right mind can keep all these things in their head, right? This is just so complex, right? And so what this is this is a graphical depiction of a scenario where you have a public instance. Okay, 3 public instances. So this is the internet gateway. There's a route on a route table with a route table association in a subnet. 3 instances in the subnet that are public. Okay, and that might be fine. They're test servers, right? They're doing something, but then they all have an SSH key. And then in this case, that SSH key is also being used by another server that's not public, it's private, but that server has an admin IAM profile. So if this SSH key were compromised for these test servers, which, it's just their test servers, then somebody can get on these boxes. They can move laterally to this instance, which has IAM admin rights. You can do anything in the account. It can take over the account completely. So finding this connected threat through the console where you've got hundreds of instances running with, dozens of subnets, routes all over the place. Who can possibly kind of keep that in their head, right? It's just not possible. And so the graph model lets you look for possibilities, right? It looks for what could happen. You can define what could happen, right? Very flexibly. And so anyway, we want Rosetta to be this open platform. We want people to write applications on top of it. Right now we're focused head down on the Secure State SaaS service. But what will you do, right? Well, you could, machine learning, anomaly detection is a great application, right on top of graphs. Modeling application dependencies would be really cool, like looking up and going up or down the stack, right? So we're looking at cloud infrastructure. What about when you add Kubernetes? What about when you add service meshes? What about when you add specific application connections in there too? Like this when you start to connect the data from these different domains across the layers, you can start to write incredibly rich policies and other kinds of queries against that stuff. You know, ultimately, can we go backwards, right? Is this a reversible model? Can we go from a graph model to a cloud infrastructure deployment? You know, so then you could like copy certain components of infrastructure out of the graph and move it, or could you detect drift, changes, things like that. So those are just some examples. But what we really want to know is what you are going to build on Rosetta. That's the vision there, right? We're a ways from that, but what we need help with is actually building this, right? There's a lot of work here to do. So yeah, Plowman is here. Where's Plowman? There he is. He's helping us establish a team here. So if anybody's interested in working on this kind of stuff, I think that'd be awesome. You should talk to him. So I have a few minutes here for Q&A, and also we'll be happy to talk to anybody afterwards. So I don't know, what do you guys think?
You mentioned users can write these rules themselves. What is the query language like?
Yeah, our database that we're using is called DeGraff. It's a relatively new graph database, and it supports this a modified version of GraphQL that they have customized it's optimized for the way they store data. So it's GraphQL plus minus, they call it. They will ultimately support Gremlin as well, but GraphQL is it's very difficult to write these queries, so we are in the midst of building our own DSL to let people do that easily. So there is a desperate need for our customers to write custom queries custom rules against their data.
I have a question here.
Yeah.
It's mostly on the compliance side, because I was interested how you solve compliance issues and compliance, standards. What's the standard that you think would be appropriate, or do you plan on supporting different compliance standards?
Yeah, great question.
How do you start? Which one do you think would go first?
So we've started with CIS, which is the Center for Internet Security, and they have benchmarks for Amazon and Azure and Kubernetes and Google, and we've implemented their rule sets on the cloud environments we support. NIST, which is a U.S. standards organization, also has a benchmark. We're doing HIPAA, which is for healthcare in the U.S. PCI payment card, right? So
you haven't done all those already?
No, we haven't done those. But what you find is that there's a tremendous amount of overlap between them all, right? They call the same thing. It's the same thing is called something different in all these different places. So we tag our rules with all the compliance frameworks it supports, and then let you run reports against those frameworks, so that you can see, how much progress you're making against them. At the same time, companies want their own customized compliance frameworks for the environments they care about, right? So they want to be able to say, there are these 10 rules that we care about for every account, right? And then there are these 10 additional ones we care just for production environments, right? And also they need to be able to suppress the things, but when you do compliance, you often want to see all the data and just make notes about, oh yeah, we've acknowledged this, and things like that. So there's the security, the compliance, and the governance aspects that we want to support. Yeah.
Thank you.
Yeah.
I have a question. I calculated that AWS have one big downtime window, so something happens once a year in the US, for example, in different regions, and some companies are getting, significant amount of downtime. So can you use this to predict if you know that some service is down in some region, to try to see what is your security effect.
Yeah. That's interesting. That's a use case I haven't thought of. So more as like a monitoring. Well, yeah. I mean, that'd be tough. So our event stream is really, it's just a trigger, right? And you can take that trigger into your domain plugin and do anything you want with it. So, sure, anything's possible, right? That we're not focused on that. And if the region was down, we just wouldn't get any CloudWatch events for that region. So we wouldn't ever be scanning those APIs and having failures on those APIs, right? So that's not what we're set up for right now. But I think that's an interesting application. Yeah.
The service that you described, is it usable? Can the AVS user buy it or use it, or is it in development?
The Rosetta service?
Yes.
Yeah, so it's in development right now. I would call it in an alpha state, and we're not at this point opening it up to anybody except the Secure State SaaS, right? It's for private use right now because as I was saying, when we were acquired, it was all one combined thing. I mean, it's built out. It's all microservices. It's decoupled. It's horizontally scalable, but the APIs were all internal, right? And so has taken a lot of work to decouple those, and make public APIs, and we're still on that journey. So yeah, it's not available. It probably at least a year before that will happen. Yeah.
Are you planning to open source this, or?
Certain elements will be open source, like some of the rules will be open source. Some of the domain model plugins might be open source, right? So right now our rules are open source. Everything else is closed. Our CLI, I guess, that's open source.
So you are somewhere on GitHub?
Yeah. Under Cloud Choreo. Yeah, under the old name. Yeah.
Another question. Why did you use DeGraff for the database?
Yeah, great question. So DeGraff looked very promising for horizontal scale, and then they support snapshot isolation as their transactional semantic, and that was really important when you're putting a subgraph at a time, inserting a subgraph at a time into the database. That has to be atomic as an operation, and DeGraff has that support out of the box. So it was those two things: the horizontal scale and the snapshot isolation. As it turns out, it's a new technology, and we often question the wisdom of going with a relatively new database, because databases are hard, and their scale out features have been slow to come and buggy. So we often ask ourselves the same question: why did we pick DeGraff? But on paper, it's really fast as well. So it's an in-memory model, and so it can be expensive to operate, but it's very fast, and real time is important to us. Yeah.
What would be the pricing model you're going to use?
Yeah, we charge for Secure State, right? There's no we haven't identified a pricing model for Rosetta so much, but for Secure State, the way we charge customers is how many of certain types of resources we're tracking in the graph. So we want it to be reflective of the amount of spend that's happening in the cloud, right? So it should be representational of that, which is in line with the way cloud management platforms work and other things.
So each object of this graph, is it what do you define? Yeah, it's more infra object, or can you because you mentioned that you'll be using the object-oriented approach. So can you define a data model, and then on top of that data model define a system architecture or application or cluster of applications and use that to define, to like find issues like one RDS has, for example, access to, or one of the users define this RDS have access to like in the other applications, like, you know, for example, two apps using the same database access credentials, or like something like that.
Yeah, certainly. So I think of that more as like that it'd be like the schema, right? Is you do the schema, you'd use the schema to define what's an RDS and to define what's a user, and you would just want to find where, you know, different RDSs that match certain patterns, instances of these schemas, you know, are connected to the users, kind of thing. Yeah. So in our Azure Service Adapter, in our Azure plugin, it is very much an object-oriented approach, right? So each service kind of ends up having a class that defines the subgraph. Yeah. What do you guys think? All right. Great questions.
I have a question.
Yeah.
Is there a way to define some security measures? I mean, some predefined hooks. For example, when you receive a security alert, I mean, what happens next?
Yeah, that's a great question. People always want to remediate, right? They want to understand how to fix the problem, and so we actually had a guy in VMware kind of acting as like a customer, and he wrote a little Slack Slack app that took the alerts out of Slack, processed them, and then went in and, you know, he wrote this whole like framework that can then go in and make Amazon calls to fix the problem. And so and we very much, whenever, we're finding that that's a question everybody's asking. So that's really astute, right? It's like, you know, how do we remediate these problems? And you got to realize, like, so there's two really key aspects to this. One is nobody wants to give secure state write access into their cloud, right? Nobody wants to trust a SaaS with the keys to the kingdom, right? So there's this privilege separation issue, right? So how can you signal effectively and close the loop? Because you need to know what's happening, right? You need to know when things remediate. How can you signal and close the loop in a way that companies will be comfortable with? And then the other is, you know, you don't want to just remediate every violation. Like for example, if the RDS is public, you know, remediating a public database, it's not trivial, right? You have to snapshot the database, you have to delete the old one, spin up a new one, restore the snapshot, and then, you know, so you're not going to just go like, just auto remediate some of these things. But what we're finding is there are certain, like these low false positive scenarios where there's a contract, an implicit contract between the DevOps teams and security or compliance, that if these violations are found, we will auto-remediate these things, and we will make you abide by the contract that you have signed, right? Like as part of using cloud within this enterprise, right? But these are really obvious things, like for example, the read-only role that Secure State uses to audit the environment. I don't think any team would say, you know, if that role permission gets changed or disabled, that there's any problem to go in and re-enable that or reset the permission, right? And nobody's going to argue that. So there are things that you can auto-remediate. You know, if you're taking CloudTrail, putting it in a bucket in a different account so Splunk can ingest CloudTrail, nobody's going to ever argue that if that bucket gets deleted or if that CloudTrail gets turned on, that we can go re-enable that functionality automatically. You know, so there's these certain things that nobody, you know, that it makes a lot of sense. And then in others, right, there's going to be a workflow around that. And so we have in our minds this collaboration model goes both ways. One is when the teams, the DevOps teams, when they get told, hey, you're violating some rule, they want to tell the security teams that they want to suppress that violation. Hey, this is the way it should be. So please suppress it. So they'll make a request to suppress. The security team will be like, okay, yeah, that's not so bad. Okay, we accept. But then the other way is security team's going to say, hey, we see this critical issue. We want you to remediate. So they'll make a request. We'd like to remediate it this way. So they'll make a request to the dev team and say, hey, we'd like to remediate. And they'll have to approve that request, right? So it's kind of this bi-directional collaboration. And we want to make that possible. Yeah.
We support third-party services like Cisco virtual routers,
No, not at this point. But that would be, that would just be a domain plugin, right? You need the APIs to query that infrastructure, model it, and find the challenging part whenever you're going to cross these services is to find identifiers where they meet up, right?
When you want to do a complex route, you usually use kind of Cisco virtual router, so there are rules. You can have an issue there. So.
Yeah, that becomes the advanced usage, double black diamond usage of Rosetta. Yeah, we haven't done any of these. We haven't done these like cross-domain rules yet. We haven't figured that out. What's the right way? Yeah.
How do you protect data that is collected and your APIs?
And what was the last part you said?
Your API.
In our API. So we have a multi-tenancy model where all the data for a specific tenant is namespaced, right? And we just enforce that that queries coming in are mapped to the right tenant. That we put in sort of operational fields that are not visible to the user that do the tenancy for us. So all queries, when they come in, they get a tenant identifier like inserted into them, right, templated in, so that we make sure we enforce that we're only querying data for the certain tenant. And the same when data is written in, we namespace that data with their tenant ID as well. So. Mm-hmm.
And also I have one question. Do you do some sort of real-time monitoring on the service?
Oh, yeah.
On the infrastructure?
On our infrastructure?
Yeah.
For our SaaS? Or yeah. Oh, yeah.
Because will it function correctly if, let's say, I drop it in a DigitalOcean instance or in AWS or in Google instance? Will it function? Exactly the same.
Well, so our service is, we own and operate our service in Amazon. It's all in Amazon. So there's no, on-prem version. Is that what you were getting at?
Yeah. Kind of.
So like even when you write a domain plugin, we run that code, we execute that code for you. So am I answering your question? Yeah. Okay. Wow, great questions. Yeah. Sorry.
You had one example with SSH keys.
Uh-huh.
What do you do about log scrubbing or obfuscating this data? Or you just get you don't get any sensitive data inside?
Right, I see. So yeah, we're not storing, we're not getting the private key of the SSH key, right? So we don't have that.
Like hash, or what do you do?
Yeah, there's the fingerprint.
Okay.
Yeah. Mm-hmm. Yeah. So yeah, I would say that in Rosetta, we tend not to have sensitive data unless, except to the extent that the configuration of your infrastructure is sensitive data. But there's not we don't have the database contents in the graph, right? So yeah. Did you have a question?
Yeah, what is the boundary of this graph? You mentioned you get a reader account, so it's just this account. Can you do cross-account graph matching?
Can you ask that again for me?
Imagine I have two accounts
Uh-huh.
that are sub-accounts of another account.
Oh, sure.
Can I join those two graphs somehow?
Yes, if you can, yes, you can. So certainly, and it happens, like, when you have CloudTrail logging to a bucket in a different account. So you kind of end up with some of these naturally. But it's to the extent that the domain model plugin finds these connections and writes them to the graph. But then, so it does make it tricky because the CloudTrail in one account's writing to a bucket in the other. How much do you show about that bucket or that CloudTrail, depending on which account you're writing the query from? So even on the bucket node, the properties have to be namespaced to the tenant so that you only show the information that each tenant can see. Does that make sense?
I'm thinking of this case that due to legacy reasons, you're using two accounts for the same logical thing. So part of your infrastructure is...
I see. So you have like your, and actually Amazon says that's a best practice. You should use a different account for each kind of major component of your service, right? Like your database should be in one account and your web servers should be in another account, right? And it's very, very complicated, but so people are doing that kind of thing, and that will present additional challenges. So what we'd have to do is like define tenancy as a collection of accounts, and we do have that notion actually. So we have a team notion which is really a group of accounts in the Secure State service, and an organization is really a collection of accounts and teams. So in an organization, that's really our tenant within Secure State, and they have access to any of the accounts in their tenant. Yeah.
Sorry, some customers with, thousands of instances actually don't know what they have in real time.
Yeah.
So how accurate are these graphs? I mean, like 100%, 95%? Can you use it like an inventory or something?
Yeah, I don't think we're quite at the point where we'd say we're comfortable with you using it as an inventory, like as a CMDB, but it's pretty it's pretty darn accurate, right? We have built-in retry, exponential back off and retry, so that if API calls fail, we'll retry those. We do, but yeah, we could miss something. Amazon's eventually consistent as well, right? So at the time when you go do the inventory, you might not see it, right? So yeah, I would say it's not perfect, but it's close. Yeah. Also with the CloudWatch events, they don't cover all services, right? So you cover most of the services, most of the important services. They actually cover all services for which our rules are currently are written, and which our customers seem to care about. But if you use CloudWatch events to control drift of your model drift, then you still need this periodic inventory to close the gap on that drift for what's missing. And we don't want to run the inventory very often because that's expensive, both in terms of the graph, but also in terms of the API limits on the cloud environments. So there are horror stories where other security tools, and even us, we've had bugs, right, where we have prevented, or other services have prevented customers from deploying infrastructure because our scanning engine is consuming all of their API quota, right? So so it's something you really have to be careful about, because they'll just turn you off if that starts happening. We have had customers just kind of, this has been a while, but just say, hey, Black Friday's coming up, we're just not going to risk it. We'd like to turn it off for the Black Friday event, right? Do you know what Black Friday is? So yeah, you'll know. Okay. Do you have that here? Oh, you do? Okay. Yeah. Wow. It's gone global.
And Black Friday, they're just using one landing page, just collected views, turn off.
Yeah. Yeah.
So the tool is the service on top of AWS, Google, and Azure. Do you think that Google, Microsoft, and Amazon will provide this kind of service themselves as well? So will you have competitors there, or?
Great. Yeah. Great question. Yeah. So they certainly are each providing their own security tools. Amazon has a number of them. They have Amazon Inspector and Amazon Config, and they have now Security Hub that they launched recently. And so yeah, they certainly are. But you know, the challenges with those tools, well, certainly they're not cross-environment, right? So there's not a single tool that you can't just use one tool to get a view across all those different environments. You know, a consistent view of that. And those tools tend to be account by account focused, and furthermore region by region focused. So the usability from a security perspective is difficult. So you know, will they catch up? Maybe, but I think they're also not going to provide visibility into these, you know, these richly, you know, highly connected threats and give you things like risk scores. So I think there's plenty of room to differentiate, to provide consistency across the provider landscape. But yeah, they are, you know, security is such an important issue that they are trying to, you know, do what they need to do to satisfy customers. But they'll always, I think, be behind in that, right? Again, it goes back to that shared responsibility model, you know. So that's my opinion. Wow, I really did not expect so many great questions. Usually you leave like a couple of minutes and hope for one or two. This is awesome.
Yeah, have you considered using this for like managing dependencies for versions of vulnerable libraries or products?
Yeah, so certainly I think that layering in other risk, threat, and vulnerability information in here makes a ton of sense. And already we're starting to do this. So you guys know what Guard Duty is? I mean, Guard Duty is another Amazon security service. It's more around anomaly detection, for network activity and anomalies, and user anomalies around, you know, like lots of invalid console logins, things like that. So certainly I could see if you have an agent running, or VMware has this product called App Defense that's looking in inside the VMs, that if they are publishing vulnerability information into this graph and connecting it to the instance nodes or whatever, that you can certainly do that. And one thing we're working on right now is, you know, we give you kind of a vulnerability by vulnerability view. You know, so okay, here's an S3 bucket, or here's an EC2 instance that's you know, it's a public instance, right? It's, you know, the port 22 open. But what we need to do is show you, okay, we need to do the pivot on this object and say, this object, this instance, has all these different vulnerabilities connected to it, right? Associated with it, right? It's being probed by, you know, it's got Guard Duty findings for network probes. It's got, it's a public instance. It's got it's got an admin IAM profile, right? So, and then here's this aggregate risk score associated with it because of the risk scores of all these vulnerabilities and threats associated with it. So absolutely, we want to be able to layer different sources of information and provide the binding to the object. Yeah.
And can you tune these risk scores? I mean, can customers make it?
Not right now, but certainly that we get asked that a lot. So we have a pretty simple formula right now, a simple transfer function for, you know, how that's computed. But everybody's going to want to dial that in for their environment. Yeah.
For Azure, are you using Azure Source Graph used by cost management, governance, Azure policies, and so on? Are you integrated with this?
No, I don't. With Azure Resource Graph? Yeah, I don't think so. But to be honest, I don't know Azure very well. So, yeah, but I don't think so.
Because it's a similar graph of entire
Is
resources.
it? Azure Resource Graph, okay. I'll bring that information back. I actually haven't heard of that, so. Yeah, thanks.
You mentioned that most of those have like a security risk meter associated, right?
Uh-huh.
How do you calculate that? I mean, what is the mechanism on determining
Yeah,
the highest?
So the way we're doing that is it's pretty simple right now, like I say, but we had to start somewhere. So we count the number of first, second, and third level relationships from the violating object and pass that through an arctangent function. And so it's weighted, and so the idea being that things that are more connected are more important in your infrastructure and therefore have more risk. So there's a lot more that we'd love to do with that, but haven't. Yeah.
Do they have like a scale, for example, having your IAM admin profile and
I see. So the way we did that, so we have the severity bands, low, medium, and high, and then the risk score is kind of a delta on top of the severity band, right? So, yeah. Again, very simple.
So, what exactly are your in-house security considerations? Because this is a follow-up to one of the previous questions, where you don't hold the SSH key, but you hold the whole graph of the user account of the tenant. And this is, in fact, the more sensitive data. Well, when attacker gets the data of the client, it's half of its work done. And what you do to secure this?
Well, so we don't have a mechanism now to secure against data exfiltration, right? The only way we would maybe know of something like that is if there was like a guard duty finding on that instance that said it was being probed, from where, how much is okay, indication of brute force. Oh, okay, but if somebody stole the key, maybe it'd just be like an unusual login location,
Exactly. My question is, what happens if someone gets the keys to your kingdom, where you keep all the
right.
all the data for all your clients?
Well, so we use our own service, right? So our service monitors our service, but that's not enough, right? There's a so the security team in VMware, right? So they're doing penetration tests, they're doing vulnerability assessments, they have Splunk hooked up to our CloudWatch, right? So we have practices around account access and management. So we have to do all those things, but yeah, it's entirely possible, especially with like an insider, malicious insider, to get the keys to the kingdom delivered. So that's also, we talked about remediation and privilege separation, right? So with a read-only role, there's certainly sensitive information about how the service is configured, but at least it's not write access to that account. Is that what you were looking for?
Picture like.
Yeah.
Exactly. When the attacker may have the full picture of all your clients.
Yeah. Yeah. Well, the risk is always there, right? And it's about, risk management. It's not, you can't eliminate risk, you can only manage it. And you can't manage what you can't see. So you have to start somewhere. You have to do something. Putting your head in the sand is not an option, right? So and furthermore, building this out for any company to kind of build this out on their own would probably be just as risky in some ways, because that's a tremendous investment to build and maintain tooling like that. So.
Do you have enterprise customers?
Oh yeah.
Using that?
Yeah.
How do you deal with the regulation requirements?
The
regulation requirements.
Regulation requirements. What right GDPR, right, that kind of stuff. So we don't have European customers right now, but we would have to we would have to run an instance of Secure State in
Because
Europe.
most common
Right.
question will be, and this is why I ask, how do you protect your data? Not only about with multi-tenancy, that's
Yeah.
clear.
So
But also the question, how do you protect the front end, your authentication to the API?
Yeah,
Because someone
so-
can make a query to your APIs to
Right.
pull data.
So VMware has, all its compliance requirements that they put on us as a service to make sure we are doing those things properly, right? So, but, but
It's about trust.
it's what?
Again, it's about trust.
About,
We trust you that you
Oh.
keep our data.
uh-huh.
Because you have a
Trust,
complete-
yes, yes, it is. At the end of the day, it's about trust. We have to earn your trust.
You can trust our legal department, they're good.
Okay, guys, if you have any questions, downstairs there's beer and pizza, which probably Coke because we didn't expect that much questions. So let's get it downstairs and you can continue with the questions like one-on-one or whatever.
Yeah, thank you very much.